This video is brought to you by Be Quiet and the Silent Bass 802. If you're looking for a high-end but affordable case that can tame whatever beast you want to build in it, whatever high heat production beast, you should take a look at the Silent Bass 802. It's got high-grade, extra thick sound dampening mats on the insides. It comes with two interchangeable front panels and top covers, so you can have it run, fully open or a little bit more restricted in the front. It's right in the box. It has easily removable dust filters, and the motherboard tray can be inverted. So you can swap the left and right side. So this tempered glass and the metal side panel, you can swap which side those are on. So this is pretty much the ultimate in flexibility for your build. There are also three pre-installed PureWings 2 140mm fans, which I've located in the top and rear of this case. It has support for water cooling radiators up to 420mm in length, as you see here. It also has a USB 3.2 Gen 2, that's 10 gigabit certified USB-C front panel connector. We did a build video on it, so be sure to check that out. Again, thanks Be Quiet for sponsoring this video, and be sure to check out the Silent Bass 802 for your next build.
We're back with another Level 099 video, and we are going to talk about I/O and Linux. We're going to talk about standard input, standard output, standard error, redirect, and pipe. And all those things have to do with the I/O system, which is a very deep topic in Linux. And there's way more than we can cover here if you want to get down to the nitty-gritty of how I/O works. But a couple things that you need to understand is that everything is a file. When we are redirecting things, we are redirecting from a file to a file, even when we're dealing with devices. And it's also important to remember that because of that, you can do terrible things if you overwrite certain files. So if you're gonna go in guns blazing and just try things out and wreck them, we do recommend that, but don't do it on a production server. Do it on a machine you don't care about, or maybe on Linode. I wanna first take a look at the cat command. This is not directly related to I/O or pipe or redirect or anything, but I'm gonna be using it a lot because it's convenient to just illustrate these things. So I want you to understand what it is in case you've never used it. Cat is short for concatenate, and you can see the description here. Concatenate files and print on the standard output. Hey, that's what we're about to learn about, standard output. The reason I want to use cat so much in these demos is because cat can mix standard output and standard error with the same command. So just to show you how cat works, a lot of people use it just to look at the contents of a file. So I have two lists here. So if we cat list, we will see the contents of this file. List is just a file, text file. And we've got red and blue and alternating output there. And if I look at list 2, then I have some delicious fruits in that one. And that's the most basic use case of cat, is just to output a file. But if you give it both files as arguments, it will concatenate them and print the entire list. But what makes cat so useful for our demo is that error output can be mixed in with this. So let's give it a good file, a bad file, and another good file, and take a look at that, and look what we have here. This is standard error. So we have standard output from list, standard error from list bad because it doesn't exist, and then back to standard output for list 2. So this is a convenient command for showing you redirect and pipe, because we can mix up the output between standard output and standard error, and that way we can illustrate how we manipulate those things. So when it comes to standard I/O, there are three basic components: standard input, standard output, and standard error. Now, the input and output, when you're thinking about it, really what's happening here is by default, we're inputting and outputting two devices. And obviously the most common ones are the monitor and the keyboard. But we're not limited to that. In fact, we can redirect that output, and that's what I want to talk about today. And output redirection is something that is very useful, and you're going to probably use a lot if you're working with the command line. So let's go back to our cat example, and let's just concatenate our two lists. But what if I wanted to take this resulting list and store it in a file instead? Well, the redirect is simply the greater than sign and then pointing to a file, and the file doesn't have to exist. It will happily create the file. So let's do the same command again, but instead let's redirect to temp file. Temp file does not exist. We are going to create it. Now let's run, and we'll use the cat command again because that's an easy way of looking at the contents of a file, and boom, there it is. So I noticed that we didn't get anything on the screen there because our standard output, which was going to go to the screen, was redirected. It never got to the device because it went to the file instead. So that's redirecting standard output. But as I said before, there are three components: input, output, and error. So what about errors? What happens if we try to redirect errors? Well, let's do the same command. Again, if we look at list and then a file that doesn't exist. So list X, or let's just call it list bad to make it obvious. List bad does not exist. This will throw a standard error. And right now with no arguments, that standard error is going to get kicked back to the screen. And there it is. So this is an error. But how do I know that, you ask? And that's an excellent question. How do we know that this is just not more standard output? Well, there's a way to conditionally redirect output and errors separately. Standard input, standard output, and standard error all have an index when it comes to being redirected. 0 is input, 1 is output, and 2 is error. And we can actually use those indices, for redirecting into files. So I'm telling you that this last line is an error, but can you trust that? Well, you don't have to trust that. We can test it. So let's do the same output, but I am going to put a 2 here before my redirect. Now again, 0 is input, 1 is output, and 2 is error. So I'm telling it redirect only the errors into the temp file. All right, let's see what happens. Well, we got some output to the standard output. Why is that? Well, it's because we only told it to redirect standard error. So standard output went to the default device, which is the screen. And what happened with temp file? Well, let's take a look at it. There it is, containing the error. We know that that was definitely an error because we only output the errors into the file. And we know that the other one is standard output because we let standard output go to the screen. This is obviously a huge thing when you're scripting and stuff like that. Probably the most common example I can think of, if you've ever tried to recursively change permissions, or you ran a program that needed file permissions and didn't have them, and you didn't use sudo, and the user that you ran it as didn't have permission, you will get a wall of error output. Permission denied, permission denied, permission denied. If you didn't want to see that, if you only wanted to see the results of the successful stuff that your program did, then you could redirect the error output somewhere else. Or you could redirect it to a file so that it's easier to go through later if you have a massive amount of errors. Another thing that you might want to do with redirecting is you might want to redirect into a running file. Let's say that you have something on cron that's running every day or every week or whatever, and you would like to have a running collection of the output or the error output or whatever from it. Now, if we look at our temp file, so this contains the error that we had, and let's just redirect our list into the temp file. And now let's take another look at it, and you see that we lost our error output. So by default, if you redirect to a file, even if that file already exists, you're going to override it. So if you want to get around that, 2 greater thans, and this will append. So now we would expect this to be double the length, and it is. So we simply appended list into temp file, which already contained list. So if you want a running file, remember two greater thans. It's also possible to redirect both standard output and standard error at the same time to different places. So for example, let's do our tried and true. I know we want this one to be bad. We want error and we want standard output and standard error. So that will give us our standard error. And again, we can use our index to point. In this case, standard output, we will point to good. Standard error, we will point to bad. And run this. Of course, we get no output because we've redirected everything. If we take a look at good, there is our expected output from our good file. If we take a look at bad, there is our expected error. Another important way of using redirect, or one of the options when using redirect, is the ampersand. And basically the ampersand is going to tell us use the same output as this other thing. And so to illustrate that, let's generate a command that will have both a standard output and a standard error. And let's just use the basic redirect for that. So we'll cat list and list bad. List bad will generate our error. Let's output that to the temp file. And see what happens. So first thing we notice, we have an error. And we printed that error to the screen. Standard error. Which means that standard error did not get redirected. And that's actually what we expect, because by default, redirect is only going to redirect standard output. If you want to do something with the error, then you have to do that explicitly. Otherwise, it's just going to go to the standard device, which is the screen. But what if we run this file again and we tell it we want to put the error output? Remember that 2 is the file descriptor index for standard error. So now we're saying take the error from this and put it somewhere else. But instead of giving it another file name, I want it to be in the same file. And what I can do there is I can use the ampersand, and then I can give it the index of the standard output. So what I'm saying is use the cat command, take these two variables, concatenate them together, redirect the output of that away from the standard output into temp file, but also redirect the output of the standard error and put it into the file descriptor 1, which is standard output. And let's take a look at temp file after that. And there we go. We have the error as we expected, as well as the standard output. So by default, you will never get standard error in a redirect. You must explicitly do something with standard error when you redirect things if you want to keep it. Otherwise, it's just going to keep going to the screen. Now, this isn't the most readable command, and there is a very handy shorthand for dumping both standard output and standard error to the same location. So instead of running this, what we can do is, instead of supplying an index before the greater than, we can just supply the ampersand. And once we do that, we're telling it redirect both standard output and standard error into our file. And we get the same result as if we did it the long way around, referencing, with the ampersand and the index. But in this case, it just automatically does both of them to the same place. You may be wondering when I'm going to talk about standard input, because that is the 0 element. We should start with that, right? And the reason I didn't want to talk about that yet is I want you to understand standard output, standard error, how we are basically just redirecting everything. Everything is a file. Even the devices are a file in this case. So, and you can do interesting things like you can redirect to /dev/audio and play audio if it's set up correctly to do that in your Linux system. So devices and files, everything's interchangeable in this. But when it comes to standard input, I wanted to wait to talk about that after we had talked about the pipe, because understanding standard input and standard output is important when understanding the pipe, because basically the left side of the pipe provides the standard input for the right side of the pipe. So let's just take a quick look at that. And again, we have list and list 2, and the top list is red and blue, the bottom list, delicious fruits. And so let's say I'm taking a look at this list and look at all these duplicates right here. I want to clean this up. I don't want duplicates. So what I can do is I can use the pipe. So again, cat list and list 2, we know what the output of this is going to be. We see it right there. But I want to get rid of the duplicates. So actually there's a command line tool for that already, unique. And so by using the pipe, I take the standard output of my cat command and pipe it into the standard input of my unique command. So let's see what we get there. Interesting, but not what we expected. Let's go up and take a look at the original list. You see here we have blue, blue, red, blue, blue, red, red. In our output list, we have red, blue, red, red, blue, red, blue. Well, why is that? It has to do with how unique works. Omit repeated lines, meaning they have to be adjacent. If they're not right next to each other, it doesn't consider them repeated. So it doesn't do what I wanted, but it's fine because the pipes can be, you can use as many pipes as you want. And it's a very simple thing to fix this, to do what I want, by adding another program in the pipeline. So instead of passing the output of cat to unique, what I'll do is I'll pass it to sort instead, which should sort my reds and blues, make sure they're all adjacent, then pass the standard output of that to the standard input of unique. And what we should get then is only one instance of red and blue. And there it is, sorted. Beautiful. We did exactly what we wanted by daisy chaining input and output through the pipe. But let's say that we want to go a little bit further with this. I mean, I have this list, but I'd kind of like to put this into a file, maybe that I can work with later. So I could go back and redirect. Obviously, we just learned if I ran this and redirected this into temp file, and then we take a look at temp file, it's exactly what I expect. And I could go into an editor and I could edit that and I could make changes and I could save it to different places, and that's great. But I don't have to do that. Again, I have the pipe. Why not just go directly to the editor? And I do this as an example because it's important that you understand how your program reacts to standard input. Now, I use Vim as my text editor when I'm on the command line. So why don't I just drop this whole list into Vim, and then I can edit it however I see fit, and I can save that file. It'll save me a step. I don't have to write it to a file, then open that file, then edit that file, then save that file. I'll just go directly into Vim. Let's see what happens. Ooh, nothing good. You might have seen that little flash. Vim did run, but it immediately exited because it was not getting what it expected. It did not expect standard input. It expected input from a terminal, as it is warning us here. And it got a little freaked out, and it's just like, I'm out, I'm done. So how do we get around that? Well, it's unique to every kind of program. And when you write a program, you can actually differentiate what happens when your input is coming from standard input or when your input is coming from somewhere else. And that's what Vim has done. But if you learn about your program and figure out how to set it up so that it takes standard input, in the case of Vim, you just add a dash. Then that's going to solve your problem. As you can see down here at the bottom, it's letting us know that it is reading from standard input because we gave it the dash argument. And here's the output that we expected. And when we drop back out to the command line, we'll actually see that it gave us a little warning before it took over the console and told us, because of the dash, that it is reading from standard input. Now, if you recall, when we use the basic redirect, we only redirect standard output by default. If we want to redirect standard error, we have to let it know that we're redirecting that explicitly. By default, just standard output. And it turns out pipe works the same way. So if we create an error situation, we know that list bad doesn't exist. We know that's going to cause an error. Let's pipe that into Vim and see what we get. And as you can see, no error output. But when we drop back to the command line, we will see the error because the error went out to standard error before Vim started. But what if we wanted those errors to be printed in Vim? What if we wanted to get everything that came out of cat into our editor instead of just standard output? Well, there's a similar shorthand, and it also uses the ampersand. The difference here, though, is that the ampersand comes after the pipe in this situation. So by adding the ampersand after the pipe, we're telling it to combine standard output and standard error into the standard input that it passes to Vim. And if we take a look at it, there we go. Our error is now included in the output that it piped out into the standard input of Vim. One more quick note on file descriptors and the index that we're using here. Let's take a quick look at, so if we cat a file that we know will cause an error, and we use the index 2, which is standard error, and we output that to error file. It's important to note this is the file descriptor index that points to standard error. Now you may come across something someday where you see something like this. What is 4? We only know about 0, 1, and 2. Well, you can have custom file descriptors. And this is way beyond the scope that we want to talk about today, but just be aware that when you write your own program, then you can have custom file descriptors that can be used to output other things. Whatever you feel like you need to separate from standard output and standard error, you can do these on your own. So when you see something like this, you just know that someone has created a custom file descriptor and they're doing something with that. As you can imagine, when it comes to piping things together, you can create these really crazy long chains, and it can get pretty confusing with what's going on, especially if you use some of the more advanced syntax. And you can even combine redirecting and pipes, and it can get crazy. And people use this to great effect in bash scripting. But one thing that's cool that you can do here is you can look at the pipe status. So let's do a quick pipe. We'll use the same one we used before. We want a concatenate that has an error in it. We'll pipe that into sort. We'll pipe that into unique, and we'll pipe that into Vim. But I am not going to warn Vim that standard input is coming. I want it to fail. So let's run this. We've seen the output of this before. What happens is Vim can't get it done. So we get the cat error output as we expect. Then we get some Vim errors here, and Vim tells us it's finished. So a lot of stuff happened there. Some stuff worked, some stuff didn't. How do we know? We have this cool thing called pipe status. So if you echo $pipe status, I'm not going to try to read that. You can read that on your own. If you use this and you echo this, it will actually show you the status of the previous pipe that ran. That's what the @ tells it. So 1001, and those correspond to the commands that we ran. So first off, the cat command exited with an error. So it returned a 1. It did not exit cleanly. Then sort, everything was fine with sort. Everything was fine with unique. We get zeros in both cases there, clean exit. Then we get to Vim. Vim did not exit cleanly because it wasn't expecting standard input. So once again, we get a 1. If we run the command again and tell Vim to expect standard input, and then we'll do the pipe status again, we get the 0 in the end because in this case, Vim exited cleanly. So if you're doing large chains of pipes, especially in a bash script, and you're not quite sure where things are failing or what's going on, pipe status can be your friend. I'm gonna be honest, I don't use input redirecting all that much, except for with the pipe. But when we talk about just redirecting standard input, almost never do it. Let's create a quick file, and we'll redirect the output of this cat command into temp file. And then we'll look at temp file. Okay, that's what we expect. Now, the redirecting input is, redirecting output is greater than, redirecting input is less than. So it works the same way. Let's take Vim, and we'll do Vim dash because we want Vim to expect standard input from the command line, not from the terminal. And then we will redirect the standard input from the temp file that we just created. And there we go. Vim has opened and it has read standard input from the file that we used the redirect. Again, I don't use it very often, but it is possible. And when you are bash scripting, that would make a lot more sense, because it would make more sense in a bash script of why you would want to redirect input. So there you go. If you've learned about I/O, hope it was helpful to you. Check out the other videos in the 099 series. We're going to try to make more and more of these to get you started, to ask the questions that you didn't even know you needed to ask, and let you learn things. And we're going to try to branch away from bash and maybe even the Linux command line, although people really like those and they're super popular. But always remember, let us know what thing that you would like explained, that you've always wanted to know about computers, but you're afraid to ask.